So, here we go. Can you identify key features of square and cube root graphs? Just like the last 2 days, you should be able to describe the transformations. So, you don't have to write this down, but y'all tell me, what does this 2 do to this graph? Vertical stretch. What does this +4 insider do? Shift up, down, left, or right? Left, because insiders lie and they're horizontal, right? Outsiders, so the -2 goes which way? Down 2, okay? Now, I think you could describe it, which you're going to need to do on the notes and the assignment for the next unit, but you also need to be able to find intercepts using your calculator. Do y'all remember doing menu 5.1? I know that was last year. Thank you. That was a good one. All right, so, but let's try to do this real quick. Let's type it in our calculator. All right, 2 square root x + 4 -2. Now, some people keep messing this up. If the -2 is after the square root, you gotta actually go to the right and do it after the square root, right? So, again, you're not looking up here. Look at other stuff. Look up here. So again, you tap it in correctly. You hit enter. Apparently, I didn't type it in correctly. So what did I do wrong here? I didn't put an X. So that's rookie mistake. All right. Type it in correctly, hit enter. Now I want to get these intercepts, so I'm going to press menu 5.1. It's going to pop up right there. When you go left and right, it's going to usually pop up with the name of it. So you see in yellow, it tells me that's the y-intercept at 0, 2. So the y-intercept is at 0, 2. And then if I just go to the left and trace it, I can get the x-intercept. Now, this says 0. Do y'all know 0 is the same thing as x-intercept? 0, x-intercept. What are 2 other names for that? 0, x-intercept. 2 more words. They mean the same thing. Not origin. No. Now I know we did this, even though it was last year. Remember, we went over, there's 4 phrases that mean the same thing. So again, x-intercept, zeros. What else? I'm not even paying attention.
It's been like 2 centuries for us.
Now for you, it was literally last year and last year. You know what I'm saying? Like
Yeah.
last year, but last year. But last year. Okay, x-intercepts, zeros, roots, and solutions. Does that sound familiar? We did this like over and over and over in my class. We went down the rows. Everyone said one. Y'all remember that? Okay, well, don't forget stuff for the new year. Alrighty. Now. Wait, what?
Thank you.
Okay, so the x-intercept or the 0 is -30. Okay, so you got your intercepts written down for your warm-up. We're going to do 6.2 notes. Let me pass this out. This will take some of your focus. You are planning on checking it out, looking at the inside of your eyelids, looking at your phone, looking at other weird things. Don't do that.
I do your notes for you.
I know, but it's pretty much the whole show.
That's just for graduation. It's literally for graduation.
It's not even the show. I know. The only thing I have for cards is that my binder. I totally don't have my binder.
Here we go. So, again, I need everyone to stay focused. So, phones away, headphones out of our ears, looking, please stay focused. 6.2 notes. We're going to talk about key features of square root and cube root graphs. So, this part is not on your sheet, okay? So just look up here. I showed you this on the last notes, okay? A quadratic looks like this. And if you take just the right side of it and you flip it across that diagonal line, you get the square root function. So does everyone see that blue thing is what we talked about the last unit, or the last section, last couple days? The red thing is what we talked about last year when I was actually here before the beard. Where did that go? All right. In the trash. Down the drain would clog. You know what I'm saying? All right. Now, this is also not in your notes, but look right here. The domain of the parent function x, square root of x. What's the domain? How far to the left does this go? At 0 to, arrowhead means infinity. Now, you could say x is greater than or equal to 0, or, do y'all remember this interval notation? 0, comma, infinity. Okay? So we're getting back into that interval notation, right? Is everyone looking over here? Okay. So 0 touches, so you put a bracket. Infinity has a parentheses. That's very important. Range, how far down does this go? What's the y value right here? 0, and it goes up, 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 up forever. So it's very similar. Y is greater than or equal to 0, or 0 to infinity. Okay. You have to be able to do domain and range of these functions. So does everyone know domain is left to right, range is bottom to top? Now, x-intercept, where does it touch the x? Where does it touch the y? No. Where does it touch the y-axis? Where's the vertex? Oh, because you can answer. What is it? What's the vertex? What's that right there? Oh, thank you. 0, 0 is the vertex. That's where it would turn around and make a C shape, but it doesn't. Okay, now that's the that's the square root of x. Let's do some examples. Y'all ready? We ready. We ready. We ready for math. All right, now, transformations. What does this 3 do? What does this 3 do? Vertical stretch. What does this plus 2 do? Up, down, left, or right. Which way does this shift? Left. Okay? Because insiders lie. They lie and they're horizontal. So left 2, and then up, down, left, or right. Which way is this minus 1 going? Down 1. It's not a line, it's vertical. So can you write that down for your transformations? We said it was vertically stretched by 3. It went left 2, it went down 1, right? When I say right, I mean with the W. Like right this down. Right? So, without graphing it, can anyone tell me where the vertex is just by looking at that equation? Yes, you can. Well, the vertex is a point, x comma y. So like, what are the two numbers of the vertex? So, let me show you where it is. Ready? Look right here. HK is the vertex. So that and that's the vertex. So what number and what number makes my vertex? Except it's an insider. So -2, comma, -1. K is not a liar. I know, there's only one liar on the inside. But let me reiterate that. The insider H is a lie. The outsider K is not a lie. That's your vertex, okay? So maybe I'll draw a little arrow here to show you. If I can find my pen. Who stole my pen?
Someone steal your pen, sir.
last time, it was like in a very obvious spot, and now it's not.
It's in your pocket.
It's a special pen. Very special pen. Unless it drops it. Golly. Found it. Okay. Found the pen.
I saw that.
Wow. Wow. All right, so check it out. Insiders lie, left 2, which also tells you that's the vertex. Outsiders tell you up and down, and that's the vertex. Okay. So do you see that these numbers tell you where the vertex is? Okay. Now, x-intercepts and y-intercepts. You can't get that from the equation. You're going to need to graph it and do menu 5-1, like we did on the warm-up. Okay. So I'm going to move this over here, and I'm going to pull up my calculadora. Okay. Calculadora. And then let's go ahead and graph this thing. So I'm going to type it in. 3 square root x plus 2. Go to the right, minus 1. Okay, what do I press? Menu. Bless you. Menu what? 5-1. Menu 5-1. And then I'm going to start tracing it. Here we go. The x-intercept, when I go all the way down here, is negative 1.89 comma 0. Do you see it over there? By tracing it. And then if I go to the right, I can trace it all the way to the y-intercept. Do you see over there that the y-intercept is 0 comma 3.24? I know it's right here, but do you see how to get it using your calculator? Menu 5-1, trace it, okay? Cool. Hello. Need things to work out for me right now. All right, now, real quick. When I could scream, but I won't. Okay, now this equation, sorry, this graph looks something like this. Okay. Now you tell me, domain and range. How far to the left does our graph go? To the left, right? So it starts at -2 and it goes how far to the right? To infinity. So it's -2 to infinity from left to right. So our domain will look like this. -2 with a bracket, infinity with a parentheses. Now don't get tricked like last period. For range, how far down does this go?
-1.
-1.
And up it goes infinite, right?
Up forever with that arrowhead.
But
-1
so not
to infinity, right? Yeah. They rock? Okay. So -1 to infinity. Is everyone good on that example? You can describe the equation. You can find the vertex. You can use your calculator to get the intercepts, and you can tell me the domain and range. Okay, example 2. Ready? You could. It's more complicated.
Yeah.
I'm trying to give you tools. Little shortcuts, hopefully. All right. This has a ton of transformations. So, help me out here. What does this negative do? So, real quick. So it does reflect it over the x. So the very first negative reflects it over the x, And then you were right. 1/2 is less than 1, so it's a vertical. You said it. So, oh my gosh, compression. Thank you so much. So it's reflect across the x, vertical compression, and then what about this negative right here? What does that do? No one? Not one? Not one soul. Mr. G pops in. It is a reflect across the y-axis, okay? If you look at your notes from 6.1, it was step number 2. What?
Oh my gosh.
Yes. It's gone. It is gone. All right, so reflect across the y-axis if it's on the inside. And then remember, insiders lie, so this goes to the right 2, and this goes down 1. So let's go ahead and write all that down. There's 5 different transformations. So you can write with a W the right way.
How would that look like if it reflected across all this?
So we are going to put it in the calculator, and you'll see it does this, like flip down, flip sideways, and it's compressed, and then shifted. It'll look really weird. It basically looks like this. Okay, I'll be impressed. Who can tell me the vertex point just by looking at that equation? How about you, students who missed yesterday on your phone? What's the vertex? Except it's a lie. Positive 2, comma 2, negative 1. That's your vertex point. Please remember, insiders lie. Okay, so 2, negative 1. Very good. Now, once again, we're going to take this to the calculator so we can use menu 5.1 to get these intercepts, okay? So keep that. So I go to my calculator, don't save, go to my graph. Negative, how do I do a fraction again? Control to divide, 1 over 2. I know that was last year when we did this, but negative 1/2 square root, negative parentheses, x minus sign 2, parentheses, go to the right, minus 1. And I don't know why that was there, so let's try it again. There you go. No, negative. Okay, so if you type it in correctly, you hit enter, you get that. So you asked what it looks like, and that's what it looks like. It's kind of weird. It's going like the opposite direction, compressed, shifted. Now, if you were doing the x-intercept, can you see how it starts here below and it goes down? It's never going to touch that x-axis. So if it doesn't touch the x, you got to put none, okay? But I do have a y-intercept. I can see it right there. So I'm going to press menu 5.1, and I'm going to go there. It pops up immediately. My y-intercept is 0, negative 1.71. Cool? But you know why and how I got it, right? Menu 5. For those of you shaking your head, you graph it and you press menu 5.1. The hardest part is probably typing it in correctly because look at that. That's got a lot of opportunity to type the wrong thing, right? Now, the domain. Check it out. If it starts right here and it goes forever to the left, okay, my first number, the forever to the left, is going to be negative infinity, right? So it's negative infinity all the way to 2. You see how domain works from left to right. negative infinity all the way to 2. Range, this goes down forever all the way up to negative 1. I want you to see, when I'm doing domain and range, I am using my vertex points. See that? Okay. What matters is which direction is it going. Okay, so please remember, domain is left to right, range is bottom to top. So make sure you have this slide filled out for example 2. Like this. So again, domain went forever to the left, all the way here to positive 2. The range went down forever, all the way up to negative 1. Are we good on example 1 and 2? Go ahead and turn to example 3. Oh yeah? All right, here we go. Example 3. Now, before we get there, look right here. I showed this on the last notes. Kind of looks like DNA or whatever, right? You got your x cubed, the red one. You have your cube root, the blue one. They're symmetrical across this diagonal dashed green line, y equals x. Okay, so we know those are inverses because they have symmetry. And don't write this down, but this is what we showed on the last notes. This is the parent function. And the thing that I noticed that's different is that it goes not only to the right, but it goes also to the left forever. So look at my domain and range. It's always going to be all real numbers for a cube root. Okay? And in this case, the x-intercept and the y-intercept are both the origin, only for the parent function. Now, here we are. Example 3. I've got a cube root function. I see that little 3 there. I see 2 transformations. Which way did it shift? Left 2, up 3. Okay, so left 2, up 3. That's it. So write that down for your transformations. No, HK are in the formula itself.
Yeah.
So what? So to answer your question, what's H? But it's a lie. Negative 2, and what's my K? So HK, it's in the equation, negative 2, comma 3. Don't forget, insiders lie, that H is a liar. All right, now, what we're going to need to do is take this and put it in our calculator so we can get our intercept. So let me drag this over here. I'm going to, by the way, if you weren't here or you forgot, how do I make a cube root? What buttons do I press? Before the caret, we press control. So control, caret. And if you hit control caret correctly, you'll have a little box right there for the caret, sorry, for the cube part of the root. Oh my gosh, what's going on here? Okay, control caret, cube root. I'm going to go to the right and put x plus 2, go to the right, plus 3. Okay, you should get this graph. Now, how do I get the x-intercept or the y-intercept? I'm going to press menu what? 5, 1, okay? Now, I can already see my y-intercept right here. It says it's 0, 4.26. Easy, okay? Now, pretend like this is not here. I don't see the x-intercept, but I know it's going to get closer as I keep going to the left, right? So like, I know it's kind of like annoying, but you would have to like click left, and you're like, okay, we're going left, we're going, we're getting there, we're kind of getting closer. It's taken like a million years, and we're almost maybe kind of getting close, and we're still not even close. We're not even saying x-intercept yet. Keep trying, and I finally almost get there, and it's almost there. Okay, so when I finally get to the word 0, I know I have to x-intercept, which is -29, 0. Cool. What's another name for a root? X-intercept. What else? 0 solution. Root 0 solutions x-intercepts. You got to know they're all the same thing. Okay? That's Algebra 1 stuff. Hopefully you were in an Algebra 1 class and not a Zoom video thing.
Yeah, I was surprised with Zoom.
Some of y'all. Okay, now that's example 3. Let's look at example 4. What's the only thing added on example 4 here? Everyone look, look, look. What's in front of this? What does that do? Numbers out front do a vertical something. Vertical what? Okay, 4 is bigger than 1, so it is a vertical stretch. So go ahead and write that down on example 4. It's a vertical stretch by 4. Okay? Now, here's the deal. H and K, what do you think H is? What? Well, it's not X, it's whatever's after X. What do you notice about H? Zero, it's not there. Hey, what about K? What's out here? Nothing. Okay, so here's the deal. If you don't have numbers, then those are zeros. Does that make sense? Okay, it didn't shift left or right or up or down, so it must be at 0, 0. Go and write that down. Okay, and then once again, can you graph it and do menu 5-1 and get your x-intercept and your y-intercept? So this is what? 4 cube root of x. Looks like that. Does everyone agree? My x-intercept is at the origin. My y-intercept is also at the origin. And like I told you earlier, cube roots go forever left, forever right. So your domain and range are going to be the weird R, all real numbers. That should make sense, but it doesn't stop anywhere. If it doesn't stop, it has to be all real numbers. Okay? So that's your example 4. Does everyone have that down? And I hope everyone's heard me. This can be easy. When you see a cube root, you know it's going to be all real numbers, for sure. But the square root, that's the one you got to think about. Where does it stop? Okay. Real quick, we got 2 more to do because you have to be able to work backwards. Now, flip it over, look at example 5 for me, please. Don't draw hearts. Don't make a note. Don't block out the word example. I'll show you guys. Don't. Now, example 5. Before we get the equation, let's ask the question. What's the transformation? This usually starts here. So how much did it move? Up 2. I know it looks like 1, but it's like, it says 2. So it shifted up 2, and it did not go left or right. So your transformation is just up 2. That's it. Now don't get tricked. What's the vertex if it's right there? Remember, a vertex is x comma y. What's the coordinate? Okay, 0, 2 is the HK. It's the vertex. Okay. All right, don't get tricked. Ready? What's the x-intercept? Well, 0, 2 is up here. No, it doesn't touch there.
None.
None yet. All right, so none, it does not touch the x-axis. Sometimes there's a none, right? So there is no x-intercept. What about the y-intercept? What? 2, okay, or 0, 2. Domain, left to right, okay? How far to the left does this go? 0 to infinity. Very good. There's no beyond. All right, and then range, how far down does this go? So what's the y value right here? 2 to infinity, okay? What just happened? Oh, it's typing what I say. The AI has taken over the class.
Aha. Bang. I thought it would work.
Okay, sorry, that's just a feature on PowerPoint, actually. All right, but for real though, if I can just move forward with my life here. There we go. Now, the equation, if all it does is move up, then I'm going to put the square root of x, and I need to have like a +2 somewhere, right? Is it going to be under the square root or after the square root? Okay. Vertical up 2 is going to be after the square root. So it looks like this. Ready? Boom. Doesn't that make sense? Square root of x, move up 2. That's what we did. We moved it up 2. On tomorrow's assignments, you got to be able to do some of these where you're working backwards. So again, that's why we're going over these. Let's do example 6 real quick, and then we'll call it a day or something like that. Oh, all right. Not a lot of time. Here we go. Transformations. Let me tell you real quick. This is where the vertex is. It moved to the left 1, and it moved down 2. Going right down, left 1, down 2, with a vertical stretch of 2. If it moved left 1 and down 2, my HK is -1, -2. And you can see it right there on the graph. -1, -2, boom. What's my x-intercept right here? Well, what number is this? 0, 0. What's my y-intercept? 0, 0 as well. This should be the easiest thing you answer all day. What's the domain or range? Another way of saying that is you write that symbol. What's the symbol look like?
R.
The weird R. All real numbers, okay? Again, if you have 2 arrowheads like this, all real numbers, all real numbers. I know I'm moving fast. We're just running out of time. So last step. What is the equation? Here's the deal. If it goes left 1, insiders lie, am I going to put a plus or a minus 1? Plus 1 on the inside, minus 2 on the outside. Of a cube root function. This is a cube root. And since it stretches by 2, I'm going to have to make sure I got a little 2 right here. So stretches by 2, left 1, because it's a liar, down 2 is not a liar. Okay? I know that's a lot all at once. And with our minutes left, I'm going to give you this now so you have it. But tomorrow you're going to have plenty of time, hopefully, to work on this. As long as you're working in class. Okay? Here we go.